What if I told you that a signal was detected that does not belong to this time? Not from another star system, not from the depths of space, but from something even stranger, the future. Imagine for a second the very foundations of your reality, shaken by a transmission that defies every law of physics we thought we understood. A signal arriving before it was ever sent. That is not science fiction anymore. This is the story you are about to experience. The discovery began as nothing more than static, a faint hiss buried in noise, the kind of interference that most scientists filter out instantly. But this wasn't ordinary interference. When decoded, fragments emerged, patterns that shouldn't exist, sequences that suggested a deliberate structure, a message struggling to be heard. The question no one wanted to ask became unavoidable. How can you receive something that has not yet been transmitted? Let that sink in. If the signal truly comes from the future, it means our understanding of time is incomplete. For decades, physics has described time as a relentless arrow, moving forward with no possibility of return. Yet here we are, standing at the edge of an anomaly that whispers something else. Could it be that time is not a straight line, but a loop, a field, or even a mirror? Could the universe itself be capable of folding moments together so that tomorrow bleeds into today? Now picture the implications. If this is real, someone or something in the future is reaching back to us. Why? To warn us, to guide us, to ensure a specific outcome unfolds? We don't know yet, but think about how unsettling that is. Every choice we make suddenly matters on a much larger scale. If the signal is proof that the future can reach into the present, then maybe the present can reach into the future as well. Humanity may not be as powerless as we once believed, but the mystery only deepens when you realize what's at stake. A discovery like this cannot be contained. Governments want to control it. Scientists want to analyze it. The public demands answers. Yet the truth is dangerous because it forces us to confront the possibility that our future isn't written in stone. It's fragile, flexible, and open to interference. And if this signal is truly a message, then it is evidence that the future itself can change. Think carefully about that. What kind of civilization would risk altering its own timeline just to send us a fragment of information? Would they be desperate? Would they be trying to prevent a disaster? Or are we simply intercepting something we were never meant to see, like listening to a private conversation across time? If so, what consequences await us for hearing it? You see, once you open this door, you can never close it again. The moment the signal was detected, our species stepped into new territory. There is no turning back, no erasing what has been found. And whether we like it or not, the signal has forced us into a dialogue with the unknown. Tonight, you and I will go on a journey through this mystery together. We'll examine how the signal was first detected, the science that could make it possible, and the theories that range from brilliant to terrifying. By the time we're done, you will not see time the same way again, because once you accept the idea that tomorrow can speak to today, everything changes. This is not just about science, it's about us, our fears, our hopes, our destiny. And whether the signal is a beacon, a warning, or a trap, one thing is certain. You must see this to understand the world you live in. The future is calling, and the question now is, are we ready to answer? It began in silence. Not the kind of silence that comforts, but the cold absence of meaning in a stream of data that should have been ordinary. A research station scanning. Deep space for cosmic background radiation picked up what first looked like random static. Their instruments are designed to record the faintest whispers of the universe, tracing back to the birth of time itself. Every scientist working in that lab was used to noise, interference, echoes of stars long dead. But on that night, the noise was different. At first, it appeared as irregular pulses buried inside the spectrum of cosmic hiss. They weren't sharp like a radio transmission, nor were they chaotic like interference from solar storms. They had rhythm, not the kind you could tap your foot to, but the unmistakable cadence of a structure repeating itself. Patterns that refused to dissolve into randomness. The team nearly dismissed it, assuming it was a glitch in the recording system, but something stopped them. The pattern was too precise. They ran it through filters. They checked every antenna, every cable, every processor. The result never changed. Beneath the veil of static, a consistent thread kept emerging. It wasn't natural. And when the data was aligned across multiple detection arrays thousands of miles apart, the impossible became clear. Each station picked up the same signal, at the same time, with the same exact pattern. A global convergence of something that shouldn't exist. This is the point where skepticism broke down. If it were an error, it would never repeat identically across independent systems. If it were a satellite, it wouldn't appear simultaneously across observatories not even aimed at the same sky. And if it were a hoax, it wouldn't have carried the unmistakable fingerprint of physical authenticity in its waveform. No, this was something else. The signal was real. Now here's where it turns from unusual to terrifying. When scientists calculated the apparent source of the signal using triangulation, the coordinates didn't point into deep space at all. They didn't match any star, nebula, or cosmic object. The signal didn't come from out there. It didn't come from anywhere recognizable. Instead, the mathematics pointed to a null origin, as if the transmission was arriving without a source. It was as if it had been dropped into our detectors fully formed, bypassing the laws of distance altogether. That discovery shook the room. There is no way for a signal to exist without a point of origin, unless it's not bound by the rules of ordinary space. That was the first hint. The second was more disturbing. When they performed spectral analysis, they noticed time markers embedded in the transmission. At first, the numbers looked meaningless, but after hours of decoding, the truth revealed itself. The markers matched precise timestamps from the future. Think about what that means. Encoded in the data were sequences aligned to time signatures that had not yet occurred. Days, months, even years ahead of the present moment. The signal didn't just carry information, it carried a timeline that was out of sync with ours. And the deeper they looked, the more undeniable it became. This was not a message from deep space, it was a message from a point in time we had not reached yet. The scientists sat in silence, each one realizing the same thing. They weren't just intercepting something unusual. They were intercepting something impossible. The implications were too vast to ignore. If the signal is from the future, then causality, the very foundation of cause and effect, has been violated. And once that truth sinks in, you can never look at the universe the same way again. But this raises a question that cuts deeper than the discovery itself. If the signal was not meant for us, who was it meant for? And if it was meant for us, why send it now? What kind of future requires reaching back across time to be heard in the present? That is where the real mystery begins. To understand why, this discovery is unlike anything humanity has faced before. We need to step back and look at the long history of strange signals. For decades, astronomers have picked up unexplained transmissions, many of which sparked theories about alien life, unknown physics, or hidden phenomena in the universe. Some of these cases were solved, but others remain open mysteries, echoing like unsolved riddles in the cosmic dark. One of the earliest and most famous was the WOW signal, detected in 1977 by Ohio State University's Big Ear radio telescope. A sharp, unexplained spike in radio frequency appeared for just 72 seconds, then vanished forever. It was strong, clear, and exactly within the range scientists expected extraterrestrial intelligence might use to communicate. The astronomer who spotted it was so stunned that he circled the data printout and wrote one word in the margin: "Wow." For decades, no one has explained where it came from. Then there are the fast radio bursts, or FRBs, discovered in the early 2000s. These are extremely powerful flashes of radio energy, lasting only milliseconds, yet releasing more energy than the sun emits in days. Some occur only once, others repeat. and no clear source has been found for many of them. Some scientists believe they come from neutron stars or black holes, but their sheer intensity and unpredictability leave room for speculation that they could be signals from advanced civilizations. More recently, we've encountered other anomalies, signals that seem artificial, but vanish before they can be studied. Bursts that appear only once in human history, never to repeat. And let's not forget the countless reports of signals that were later explained away as interference, like microwave ovens at observatories producing false positives. These examples remind us how fragile the boundary is between what we expect to hear from the universe and what truly arrives. Yet here's the crucial difference. Every mysterious signal in the past had a source, whether known or unknown. The wow signal came from deep space near Sagittarius. FRBs have measurable points of origin, often galaxies billions of light years away. Even the false detections came from something within our own environment. But the signal we are examining now defies all of that. It has no origin. It doesn't travel through space. It appears as if it was injected directly into our present reality. That makes it something entirely new and infinitely more disturbing. Imagine standing in a dark forest and hearing a voice whisper your name. You look around, but no one is there. Then you realize the voice didn't come from the trees or the wind. It came from inside your own mind. That is what makes this signal different. It doesn't behave like any known transmission because it doesn't belong to the normal flow of space and time. It belongs to something else. The history of unexplained signals prepared us to ask questions, to remain skeptical, and to explore the edges of possibility. But none of those past mysteries carried a timestamp that pointed to the future. None of them suggested that time itself had been broken open. This is why scientists say we've crossed into uncharted territory. If previous anomalies were whispers from the stars, this one is a voice from tomorrow reaching into today. And so, the stage is set. We are no longer dealing with the familiar category of unexplained space phenomena. We're confronting a new reality in which the boundary between present and future has dissolved, leaving us vulnerable to whatever message is coming through. Which forces us to ask, what kind of universe allows such a thing to happen? And how does it work? To make sense of what we're dealing with, imagine time not as a straight arrow, but as a vast ocean. Most of the time, waves ripple forward, flowing steadily in one direction. But under certain conditions, waves don't just move forward. They crash, they fold, they overlap, sending fragments of energy back against their own current. What if time works the same way? What if the signal we intercepted isn't traveling across space, but instead riding the folds of time itself, like a ripple rebounding from a hidden shore? This analogy helps frame the impossible. If time were perfectly linear, messages from the future could never arrive in the present. But if time behaves like a wave, capable of bending, folding, and echoing, then sudden pockets of interference might allow fragments of tomorrow to leak into today. The signal becomes less a deliberate transmission and more like a vibration, breaking through the fabric of time. It doesn't have to travel light years because it doesn't travel in space at all. It simply emerges where the folds meet. Picture holding a sheet of paper flat on a table. Draw two dots on it, one at the top, one at the bottom. Normally, the only way to connect them is by drawing a line across the surface, long, predictable, and bound by the plane of the paper. But fold the sheet so the dots touch, and suddenly they are connected instantly, without distance, without delay. This is what many physicists suggest could happen if space-time itself were flexible. The signal might be nothing more than the result of such a fold, an overlapping of timelines where tomorrow pressed against today, leaving behind its mark. Of course, this raises deeper questions. If folds in time can occur, what causes them? Are they natural, like cosmic tides shifting in higher dimensions, or artificial, created by civilizations far ahead of us, bending space-time intentionally to send messages back? If it's natural, then we may have stumbled upon a universal phenomenon, that rewrites physics. If it's artificial, then we're no longer alone in the story of time. The folded wave analogy also explains why the signal appeared without an origin. If it's not moving through space, there is no trajectory to trace, no star system to identify. Instead, it materializes fully formed, like an echo bouncing into existence. That's why the scientists found themselves staring at a null coordinate, because the signal's origin is not a place, but a moment. And that moment has not yet arrived. Think about the implications of that. If the folds of time can allow signals to pass backward, what else could they allow? Could physical objects slip through? Could events replay themselves, reshaping reality as we know it? Could we one day stand face to face with versions of ourselves from futures that never were? Once you accept the possibility of folded time, the imagination explodes with terrifying and exhilarating scenarios. But perhaps the most haunting thought is this: what if the folds are not random? What if they are moments of contact chosen carefully by something or someone beyond us? If the signal has reached us now, it might not be coincidence. It might mean this specific moment in history is critical, a point where the future demanded to be heard. And if that's true, then whatever comes next may decide not just our future, but the very shape of time itself. Every mystery begins with the tools we use to measure it. Without the instruments, the signal would have been nothing, more than unnoticed static, drowned out by the constant hum of the universe. But because technology has advanced to an extraordinary level, what once would have been discarded as noise was preserved, decoded, and revealed as something extraordinary. The question is, what tools were capable of capturing a message that doesn't even come from our time? The discovery relied on ultra-sensitive radio telescopes designed to monitor the cosmic microwave background, the faint afterglow of the Big Bang. These arrays record enormous volumes of data every second, breaking it into precise frequency bands for analysis. To filter out interference, the systems run complex algorithms, eliminating signals from satellites, aircraft, and atmospheric disturbances. What remained in this case was something that slipped past all filters, not because it was subtle, but because it obeyed none of the expected signatures of known interference. It was a pattern without precedent. When the data was aligned with atomic clocks, the most accurate timekeeping devices we possess, the anomaly became even stranger. Every piece of information in the signal carried embedded time codes, as though they were stamped with coordinates, not in space, but in time. These markers were consistent across observatories, synchronized perfectly with time standards that hadn't yet occurred. Imagine reading a message where the date is always tomorrow, and no matter how long you wait, tomorrow never arrives. That's exactly what the scientists faced. To verify, the team compared their results across multiple facilities worldwide. In Europe, Asia, and South America, telescopes recorded the same structure at the same instant. The consistency was undeniable. More importantly, the signal had no measurable delay. Usually, transmissions from deep space take years, centuries, or millennia to reach us. But this one appeared instantaneously everywhere, as if it was layered into the fabric of reality itself. That discovery forced the scientific community to ask a dangerous question. Are we seeing evidence of communication across time, rather than across space? Let's consider the timeline of events. Detection first occurred late at night in a mid-sized research facility, but within hours, major observatories confirmed the same anomaly. Within days, secret briefings were held at the highest levels of government. And within weeks, whispers began circulating among scientists that this was no ordinary discovery. The problem wasn't just the signal itself, but what it implied. That our detectors may not only be picking up energy from the past, but also intrusions from possible futures. This idea is not entirely without precedent in theoretical physics. Certain models of quantum mechanics suggest that particles can exist in superpositions that stretch across time. In those models, causality, the belief that cause must always precede effect, can break down under extreme conditions. The instruments, designed only to record the present, may have stumbled into the edge of that reality. The signal becomes evidence not of alien contact, but of temporal contact. Imagine the terror and fascination of those scientists. Their equipment wasn't just showing them the universe as it is, it was showing them the universe as it might become. Every line of data was a ghost of tomorrow pressing into today. That realization reframed their role entirely. They were no longer astronomers peering into space. They were archivists of time itself. And here is the unsettling part. If our instruments can detect messages from the future, then perhaps they already have, countless times, hidden inside the archives of so-called unexplained noise. This discovery may only be the first time we recognized it for what it truly is. Which leads us to the next critical question. What happens when human beings confront something that not only breaks the laws of science, but also reshapes the very idea of reality? When the discovery was confirmed, the immediate atmosphere among scientists wasn't triumph, it was disbelief. The human mind is conditioned to reject the impossible, and that instinct was overwhelming in those first hours. Senior researchers stared at the printouts in silence. Younger scientists whispered, afraid to voice the thought forming in their heads. They had all been trained to see time as untouchable, immutable. Yet here was undeniable data telling them otherwise. The first reaction was cautious dismissal. Perhaps it was a miscalibration, a cross signal, a glitch in the decoding software. Teams worked frantically to rule out every mundane explanation. Power surges, atmospheric events, classified satellites, even the possibility of coordinated sabotage. But every test returned the same conclusion. The signal wasn't a mistake. It wasn't interference. It was real. That's when speculation exploded. Some argued it had to be extraterrestrial in nature, though this idea immediately faltered. Because the data didn't fit the model of an interstellar transmission, others wondered if the signal was a new form of natural cosmic event, something physics had yet to catalogue. But a third group began whispering what no one wanted to say out loud: the timestamps. They weren't random. They aligned with a timeline that had not yet unfolded. To admit that was to admit the unthinkable. In closed rooms, theories circulated with a mixture of awe and dread. If the signal was from the future, was it sent intentionally? Or were the instruments catching an accidental echo of time itself? And if it was intentional, who sent it? Humanity in the future, reaching back to alter the present? Or something else entirely, something with motives we cannot begin to comprehend? The tension was palpable. Governments were alerted, not out of curiosity, but out of fear. A message from the future could carry warnings of catastrophe, weapons, of unimaginable power, or knowledge that could destabilize the balance of the world. Suddenly, the signal wasn't just a scientific puzzle, it was a geopolitical flashpoint. Agencies scrambled to classify the data, to lock down access, to decide who could know and who must remain in the dark. Meanwhile, within the scientific community, a psychological divide formed. Some saw the discovery as the greatest breakthrough in history, proof that time is more flexible than we ever imagined. Others felt paralyzed, convinced that engaging with the signal was reckless. What if decoding it altered the future? What if by simply listening, humanity was interfering with something it could not understand? Think about the weight of that moment. You are holding data that suggests the future itself has broken into the present. Do you treat it as a gift, as a warning, or as a trap? Do you study it freely, or do you bury it in secrecy to prevent mass panic? Every decision carried consequences not just for the present, but potentially for the very timeline we all inhabit. The first speculative reactions were not about answers. They were about survival. No one could say for sure whether this was an opportunity or a threat. All they knew was that the world had changed, and once the existence of the signal was undeniable, the next step was unavoidable. Someone had to attempt to decode it. That decision would mark the beginning of a journey into the unknown, one that would challenge not only science, but the very definition of reality itself. Before decoding even began, the raw signal itself carried an atmosphere that unsettled those who worked closest with it. Not because of what it said, but because of how it felt. The waveform didn't present itself as clean lines of communication. It was jagged, distorted, full of gaps and sudden bursts, almost alive in its unpredictability. Watching the data scroll across the screens was like staring into static that seemed to be hiding something, as if the noise itself was a mask concealing fragments of a message not meant for human eyes. Technicians began comparing the recordings to old analog interference, the kind seen on broken televisions and dying VHS tapes. But there was a disturbing difference. In those old glitches, the chaos was random, meaningless. Here, the chaos had structure. The distortions seemed to pulse in rhythm, sometimes faintly resembling patterns that looked eerily like voices buried in the noise. Some claimed to hear whispers when the signal was slowed down, though none could agree on what the words were. Was it suggestion, the brain forcing meaning onto randomness? Or was the randomness never random to begin with? This is where the atmosphere around the discovery began to shift. It no longer felt like a sterile scientific anomaly. It felt like something alive, something that was deliberately concealing itself in layers of distortion. Observers described the signal as if it carried intent, not just information, but a mood. And the mood was unsettling, a sense of intrusion, as if reality itself had been tampered with. Imagine staring at a distorted video where static briefly clears to reveal fleeting images that vanish before you can confirm them. That was the experience of analyzing the signal frame by frame. Glimpses of shapes that might have been words, symbols, even human faces flickered for less than a heartbeat before dissolving back into noise. The scientists dismissed them as artifacts of the decoding process, yet deep down, many felt that they were being shown fragments of something beyond their comprehension. The aesthetic of the signal, its raw analog horror quality, created psychological tension. This wasn't the polished, deliberate transmission you would expect from a future civilization trying to communicate. It felt more like a corrupted recording, as though the message had been dragged through the fabric of time and damaged beyond repair. But what if that distortion wasn't damage? What if it was intentional? What if the corruption was the message itself, hiding truths that could only be revealed when the right mind, at the right moment, pieced them together? This haunting atmosphere made secrecy even more difficult to maintain. Those exposed to the raw signal found it hard to shake off. Some reported dreams filled with static, nightmares of voices calling their names. Others claimed their sense of time became distorted, losing track of hours as they worked with the data. Whether psychological stress or side effects of interacting with something beyond normal causality, the pattern was undeniable. The signal didn't just transmit information, it transmitted an experience. That experience set the tone for everything that followed. From the very beginning, this wasn't just a scientific investigation. It was an encounter with something that carried the flavor of the unknown, unsettling in ways that numbers and equations couldn't explain. It felt like peering into a future we weren't ready to see, wrapped in distortion and shadows, daring us to look deeper. And the deeper we looked, the clearer one truth became. Beneath the distortion was order, and beneath the noise was meaning. The horror was only the surface. What lay beneath was waiting to be revealed. Once the initial shock settled, speculation turned to the impossible. What if the signal was a footprint left by a parallel timeline? In theoretical physics, there's a concept known as the many worlds interpretation, which suggests that every decision, every event spawns a new branching universe. Each branch exists simultaneously, layered like sheets of glass, almost touching but never quite intersecting. The signal might be evidence that these layers occasionally brush against one another, allowing information to leak across dimensions. Imagine a universe where every choice you make creates a new path. Somewhere, in one of those paths, humanity has mastered technology that allows it to communicate across these timelines. Or perhaps it isn't technology at all, but a natural resonance, a cosmic echo that occurs when two timelines nearly overlap. That would explain why the signal arrives with no origin and no delay. It didn't travel through space. It vibrated through the folds between realities, like sound traveling through a thin wall. The more scientists explored this possibility, the more unsettling it became. If these echoes are natural, we might already be experiencing countless interactions from other timelines without realizing it. Signals that seem like coincidences, strange events, sudden inspirations, or even déjà vu could be fragments of parallel worlds leaking into ours. The signal we detected may be the clearest, most coherent example humanity has ever captured. The parallel timeline theory also introduces a profound ethical and existential question. If we can hear echoes of other worlds, should we respond? Could our actions in this timeline affect countless others? And if a message arrives from a timeline where something terrible has occurred, would ignoring it doom us to repeat the same mistakes? The very act of observation might carry consequences we cannot measure. Beyond physics, the human mind reacts viscerally to the idea of parallel echoes. It's impossible to ignore the feeling that somewhere, another version of yourself is aware of the same discovery. And if that version has already solved the problem, or already sent the message, what does that make us? Listeners, participants, or pawns in a reality far larger than we can comprehend. Artists and storytellers have long toyed with the idea of parallel worlds, but this signal turns fiction into tangible possibility. The patterns hidden within the static are no longer just data. They are whispers from a universe that mirrors our own, but is just out of reach. Listening becomes an act of connection, a brush with an existence that is simultaneously ours and not ours. And yet, the theory comes with danger. If these echoes are unstable, decoding or interacting with the signal might destabilize the delicate overlap, causing unforeseen consequences. The line between observation and interference is razor thin. One wrong interpretation, one misstep in handling the data, could send ripples across multiple timelines, altering outcomes we cannot predict. The idea is both exhilarating and terrifying. For the first time, humanity confronts a reality in which the boundaries of self, time, and universe blur. The signal isn't just an anomaly. It's an invitation to consider that every moment, every choice, exists in a network of possibilities, some of which are now speaking directly to us. If the first theory hints at natural cosmic echoes, the second theory asks us to imagine intentionality. What if the signal is not a byproduct of physics, but a deliberate attempt by a civilization far more advanced than ours to communicate across time? Think about it. Any civilization capable of sending a message from the future would have to manipulate the very fabric of reality, bending time and energy in ways that make our current science look primitive. This is no simple radio broadcast. This is mastery of causality itself. Consider the purpose of such a message. A civilization with knowledge of the future might see our present as a pivotal moment, a fork in history that determines outcomes of global or even universal significance. Perhaps they are warning us of a disaster, or guiding us to a discovery that could elevate civilization. Maybe they are observing, testing, or even recruiting our participation in a plan that spans millennia. The signal becomes less a message, and more a lifeline, a bridge between now and what must come. The signal structure supports this possibility. Embedded within the noise are patterns that suggest complex encoding, the kind that would require intelligence to create. There are repetitions that look like code, fragments that resemble instructions or sequences that might correspond to technology we have yet to invent. Every pulse, every anomaly, seems purposeful, designed to be discovered by minds capable of understanding. It's almost as if it's waiting for us to be ready. Imagine receiving a letter from someone who knows your future. That is the magnitude of what scientists are facing. The message isn't just information. It's guidance, caution, and proof that time itself can be navigated intentionally. The implications are staggering. If a civilization has mastered this, they may already know how events unfold, how history bends, and how to influence outcomes without altering the timeline catastrophically. They operate on a scale of precision that we cannot yet imagine. Skeptics immediately raise questions. How could such a civilization exist, and why would it contact us now? What are their motives, and what do they gain by reaching back across centuries or millennia? Could it be benevolent, or could it be a form of control, manipulation, or observation that serves interests we cannot comprehend? The mystery deepens with every decoded fragment. The psychological effect on the scientists was profound. They oscillated between awe and terror, realizing that if the message is intentional, it may contain knowledge that could fundamentally change humanity. It challenges ethics, philosophy, and the concept of free will. Knowing the future, or being guided toward it, might offer immense advantage, but it also imposes responsibility. Responsibility we are not ready for. If this theory is correct, then the signal is not a simple anomaly. It is an invitation, a challenge, and a warning. It asks humanity to rise to a level of understanding that spans centuries. It asks us to interpret, respond, and perhaps even act in ways that could determine whether we become observers of our own fate or active participants in shaping it. While some believe the signal is intentional, others propose a more unsettling possibility, that it is the result of a cosmic glitch, a spontaneous disruption in the fabric of space-time itself, a temporary misalignment that allows fragments of the future to leak into the present. Unlike messages from advanced civilizations, this theory suggests there is no sender, no purpose, only a universe behaving in ways we do not yet understand. Imagine a stream flowing smoothly, when suddenly a whirlpool forms, pulling in water from elsewhere in the current. In the same way, space-time may occasionally fold or ripple, creating an anomaly that projects signals from moments that have not yet occurred. These glitches are rare, unpredictable, and almost impossible to reproduce. Yet, when they happen, they create events like the one we are witnessing, an unexplainable transmission, seemingly purposeful, but entirely accidental. The scientific support for this theory comes from cutting-edge physics. Some models of quantum gravity suggest that space-time is not a perfectly smooth continuum, but a fluctuating network of probabilities. Tiny distortions can create pockets where the usual rules of causality break down. A cosmic glitch of sufficient magnitude could temporarily collapse these pockets, allowing information to escape into what we perceive as the present. The signal could be a natural artifact of this rare phenomenon. The psychological impact of this idea is profound. If true, it means the universe itself can intrude on our reality, independent of conscious design. The signal is not a message to humanity. It is a random artifact, a cosmic echo of events that may never happen again. That renders the discovery both terrifying and beautiful. Terrifying because we have no control. Beautiful because it offers a glimpse of the universe's hidden complexity. Consider the implications for knowledge and discovery. If the signal is a glitch, then other anomalies may exist, waiting to be captured by observatories tuned to the right conditions. Entire fields of physics may need to be rewritten, not because we misunderstood the past, but because the future itself has occasionally reached into the present. We may be standing at the threshold of understanding time in a fundamentally new way. Yet this theory is also humbling. It suggests that the universe does not communicate with intent. There is no higher intelligence guiding us. The patterns we see may only appear purposeful because our minds instinctively search for meaning. Every pulse, every repetition, could be a quirk of physics, not a deliberate design. And that realization forces scientists to confront the uncomfortable truth. Sometimes the universe gives us glimpses of the impossible, not to guide us, but to remind us how small and limited our understanding truly is. Whether it is intentional or accidental, the signal challenges every assumption we have about reality. It refuses to fit into categories of space, time, or causality that we consider fixed. If it is a cosmic glitch, then humanity is witnessing a fleeting event, a one-time phenomenon that defies comprehension. And if we are lucky, we may be able to study it before it disappears, leaving only echoes and questions that will haunt us for decades. Among the most unsettling theories is that the signal is not just information, not just a glitch, but a warning. A communication from the future meant to alert us to a catastrophe that could reshape our world. Unlike echoes or random glitches, this theory suggests intent behind the anomaly. Someone, or something, wants us to act. The signal may carry clues about disasters that lie ahead, events that humanity must prevent or prepare for. And knowledge we are not yet ready to grasp. Think about the nature of warnings. They are urgent, precise, and directional. Unlike casual communication, a warning arrives at the critical moment, demanding attention. This signal fits that description. Embedded patterns seem to hint at specific sequences, repeating in ways that suggest, if you understand this, you can prevent what comes next. Unlike messages of hope or exploration, warnings carry weight. They imply consequences that could be catastrophic if ignored. The psychological effect of this theory is immediate and intense. Imagine knowing that the future is not safe, that something terrible is imminent, and that only by deciphering a cryptic transmission can you hope to intervene. It introduces fear, urgency, and responsibility all at once. And unlike other theories, there is no neutral stance. Listening to a warning means participating in the fate of everyone alive. Ignoring it could mean disaster. Some speculate that the warning might relate to natural disasters, technological collapse, or even human conflict amplified to a global scale. Others consider it could be far more abstract, a disruption of reality itself caused by future experimentation, quantum accidents, or events that bend the laws of time. The signal doesn't specify, but the very ambiguity intensifies its power, keeping scientists awake at night, haunted by questions with no answers. The warning theory also forces us to confront a profound dilemma. If the message is from the future, are we allowed to act on it? Doing so risks creating paradoxes, altering history in ways we cannot predict. But doing nothing could lead to the very outcomes the signal is hinting at. Humanity is trapped between the desire to survive and the fear of interfering with forces beyond comprehension. It's worth noting that history is filled with cautionary tales. Ancient myths, religious prophecies, and unexplained phenomena often convey a sense of forewarning. Could this signal be the ultimate iteration of that pattern? A scientific prophecy delivered across the boundaries of time itself? If so, it is as much an ethical challenge as a technological or scientific one. The tension of this theory grips the imagination because it makes the stakes tangible. The signal isn't just strange or fascinating. It might be urgent, life-altering, even terrifying. And that urgency drives the next step, decoding, understanding, and confronting what may lie ahead. The warning, whether real or imagined, transforms the signal from an anomaly into a call to action, demanding attention, focus, and courage. Inside the dimly lit lab, monitors flicker with the static of the signal. Scientists huddle around screens, their faces illuminated by the eerie green glow of data scrolling faster than the eye can follow. Every pulse, every irregular pattern, sparks a flurry of activity. Algorithms recalibrating, filters being adjusted, code running in loops to decode what may or may not be a message. The tension is palpable. Every sound of a key pressed feels amplified in the stillness. The lead researcher leans forward, eyes scanning a waveform that seems almost alive. She mutters a string of numbers under her breath, matching them to temporal markers embedded within the data. Colleagues glance at her, a mixture of awe and unease in their expressions. The signal doesn't behave according to conventional physics, and every attempt to force it into recognizable patterns yields unexpected results. It pushes back, almost as if it resists being fully understood. Then, a breakthrough moment. A sequence of pulses repeats in a recognizable pattern. The team freezes, listening to the decoded fragment, realizing it carries a rhythm that resembles structured communication. Voices? No, not quite. The sound is mechanical, fragmented, but unmistakably intentional. The room goes silent, everyone aware that they are witnessing something extraordinary. They are not just decoding data, they are catching a whisper from time itself. Cameras on tripods capture the scene, showing hands trembling as they adjust. Dials, eyes narrowing at oscilloscopes, and expressions shifting from confusion to realization. This is more than a discovery. It's a confrontation with the unknown. Every beep, every visual spike on the monitor holds potential meaning, and the responsibility weighs heavily. One mistake, one misinterpretation, could distort the data, or lead them down a false path. The atmosphere in the lab mirrors a suspense thriller. Shadows stretch across walls as screens flash with static. The signal seems almost sentient, teasing the scientists with fragments of patterns that vanish before they can fully decode them. Some team members feel an eerie sense of being observed, as though the signal is aware of their attempts to interpret it. The tension between excitement and fear becomes a palpable presence, wrapping around every person in the room. The reenactment also highlights collaboration and conflict. Debates erupt over the significance of a particular pulse. Some argue it is random interference, while others insist it carries intentional meaning. Every decision about the data carries weight.
The team is operating at the edge of human comprehension, grappling with a phenomenon that challenges the very framework of reality. Through this dramatized lens, viewers experience the thrill and danger of discovery. They are placed in the lab,
alongside the scientists, feeling the anticipation, the fear, and the awe. This approach humanizes the science, showing that the quest to decode the signal is not just an intellectual challenge, it is an emotional and psychological journey into the unknown. As the scientists work, the waveform on the main monitor begins to change, not slowly but with sudden, almost violent morphing. Lines of static stretch and compress, forming shapes that seem to pulse with intention. Every shift in the display corresponds to a spike in the encoded data, each one suggesting a hidden pattern just beyond comprehension. The signal isn't static. It's alive in a way that defies conventional observation. Viewers are drawn into the visual chaos. The screen flickers between raw waveform and animated interpretations, showing how the pulses could translate into symbols, sequences, or even language. Colors shift to indicate intensity, frequency, and potential meaning. It's hypnotic, immersive, and slightly disorienting. An aesthetic designed to mirror the psychological experience of decoding a message that originates outside the normal flow of time. Each morph creates suspense. Peaks rise and fall unpredictably, hinting at intentional repetition. A short sequence repeats several times, then abruptly changes direction, forming a fractal-like structure. The fractal effect suggests complexity, beyond human design. It feels almost organic, as though the signal itself is evolving in response to observation, adapting as it is being analyzed. To capture the full effect, slow-motion inserts show subtle changes in the waveform that might otherwise go unnoticed. Tiny distortions appear and vanish within milliseconds, challenging the team to capture patterns before they dissolve. The visual becomes a puzzle, an interactive experience that keeps both the scientists and the audience on edge. Each frame asks the question, is this random chaos, or is there meaning waiting to be uncovered? The morphing waveform also conveys a sense of scale. What seems small on the monitor represents enormous temporal distances, entire future sequences compressed into a stream of oscillations. Every ripple could correspond to an event yet to occur, every spike a potential message from moments that have not yet happened. The visualization bridges the gap between abstract theory and tangible experience, allowing the audience to sense the magnitude of the anomaly. By turning the waveform into a visual narrative, the signal becomes more than data. It becomes a character in its own story. It dominates the frame, dictates the pace, and challenges perception. The morphing is both beautiful and terrifying, a constant reminder that the signal is beyond human control, yet irresistibly compelling. Every second spent watching it raises more questions than answers, drawing viewers deeper into the enigma and priming them for the theories that follow. Even as the discovery ignited awe and curiosity, a strong current of skepticism emerged from the broader scientific community. Leading physicists and engineers questioned everything about the signal, demanding rigorous proof before entertaining extraordinary claims. For them, the idea of receiving a message from the future bordered on science fiction, a breach of principles that had guided research for centuries. Their first objection focused on instrumentation. Could there have been hidden interference, subtle flaws in calibration, or undetected software errors? They examined the arrays line by line, circuit by circuit, yet the anomaly persisted. Still, skepticism remained justified. Extraordinary claims demand extraordinary evidence, and the signal, no matter how convincing to its discoverers, lacked independent reproducible verification at scale. Others argued for cognitive bias. The scientists working closest to the data were emotionally invested. Could pattern recognition and expectation create illusions of intentionality and random noise? Humans are wired to find structure, to see meaning where there may be none. Mainstream physicists warned that interpretation must be rigorously separated from imagination, that excitement cannot cloud judgment. Philosophical objections followed. Even if the signal were real, does a temporal message violate causality, or does it simply represent a misinterpreted quantum anomaly? Many researchers insisted that invoking messages from the future steps beyond testable science and into speculative theory. Without a repeatable mechanism, the signal might be remarkable, but ultimately meaningless in terms of predictive value. Yet their skepticism carried an unintended effect. It fueled debate, inquiry, and deeper analysis. For every criticism, new methods of testing were developed, pushing the boundaries of observational capability. Advanced simulations were run, data cross-referenced across continents, and every hypothesis, from glitches to natural phenomena, was explored. Skepticism became a catalyst, forcing the team to refine their approach and confront the limits of human understanding. The tension between believers and skeptics created a psychological push-pull. On one side, the wonder of touching the impossible. On the other, the cautionary voice of logic, warning against delusion. This dialectic mirrors the scientific process at its most human, the collision of curiosity, fear, and rigor. It also heightens the drama of discovery. While the audience experiences awe, they are reminded that extraordinary phenomena are never accepted without scrutiny. Ultimately, skepticism doesn't disprove the signal. It sharpens the investigation. It forces questions. If it is real, how? Can it exist within the known laws of physics? If it is illusion, what mechanisms of human perception are being exploited? And if mainstream physicists are forced to confront it, then the anomaly is significant enough to challenge the very foundations of understanding. The dialogue between astonishment and doubt drives the narrative forward, keeping viewers engaged and questioning alongside the scientists. Throughout history, there have been strange occurrences that hint at time behaving in ways humans struggle to explain. These anomalies often appear as isolated events, fleeting glimpses of something beyond our linear understanding. While none are confirmed messages from the future, they provide context for the possibility that reality can bend in ways science is only beginning to imagine. One famous example is the so-called Philadelphia experiment from the 1940s, where naval records claim a ship disappeared briefly from sight and appeared miles away in an instant. While largely dismissed as legend, the story fueled decades of speculation about time displacement, invisibility fields, and the manipulation of space-time. Whether real or myth, it highlights humanity's long fascination with events that defy temporal logic. Another documented phenomenon is the experience of sudden déjà vu, reported universally but poorly understood. Scientists theorize that intense neurological or quantum effects could create a temporary overlap of perception, a momentary glimpse into a parallel timeline or the future. Individuals report detailed visions or knowledge they could not have possessed, as if time itself allowed a brief preview of events yet to occur. While anecdotal, such accounts suggest that consciousness may sometimes interface with reality in non-linear ways. There are also modern observations of temporal anomalies in scientific experiments. In particle physics labs, rare events occasionally appear to reverse causality, particles reacting before the triggering event occurs. These occurrences are fleeting, almost impossible to reproduce, yet they hint at the fragility of our assumptions about cause and effect. They are echoes of a universe far stranger than everyday experience allows. Even historical documentation occasionally contains curious accounts. Records of prophetic visions, sudden inventions appearing fully formed, or unexplained technological insights suggest that information sometimes seems to emerge ahead of its time. Scholars debate whether these were coincidences, misinterpretations, or fragments of knowledge leaking from future events. But the pattern is compelling. Across centuries, humanity has glimpsed anomalies that suggest time is not as fixed as it seems. The connection to the current signal becomes clearer when we consider the patterns embedded in the data. The repetition, irregularities, and non-linear timestamps echo these historical anomalies, only on a scale we can measure and analyze. Unlike past cases, this signal offers tangible evidence, a record that can be dissected, quantified, and debated. It bridges the gap between anecdote and science, between myth and reality. This case study frames the discovery within a broader continuum. It reminds us that the signal is not an isolated curiosity, but part of a long human encounter with the strange, the impossible, and the temporally anomalous. The past, in small, scattered ways, prepared humanity to recognize the potential significance of this moment. And now, with the signal in hand, we are confronting the culmination of centuries of hints, patterns, and whispers pointing toward the same unsettling possibility. Time may not belong solely to the present. With human analysis hitting limits, artificial intelligence became the key to making sense of the signal. AI algorithms can process enormous volumes of data, detecting patterns invisible to the human eye and simulating interpretations across multiple theoretical frameworks. In this context, AI doesn't just assist. It becomes an extension of human cognition, capable of exploring possibilities that defy conventional reasoning. The first step was feeding the raw signal into a neural network designed to recognize temporal anomalies. The AI began identifying recurring structures, sequences, and deviations from randomness that had escaped human detection. Patterns emerged, suggesting that the signal's noise contained layers of information stacked within itself. These nested layers could correspond to multiple timescales, encoding not just immediate sequences, but potential future outcomes. AI also provided a way to test theoretical models rapidly. Parallel timeline echoes, intentional future messages, cosmic glitches. Each model could be simulated with vast permutations to see which best matched the observed data. In some simulations, the signal's structure aligned with predictions of causality-breaking events, offering tantalizing hints that the data was more than random. In others, it suggested information from advanced future civilizations, carefully embedding instructions across time. The AI's output, however, came with psychological complexity. As sequences were revealed, the scientists began experiencing cognitive overload. The AI's interpretations suggested branching possibilities, each implying different outcomes, different futures. It was as if the signal itself was a mirror, reflecting potential versions of humanity and the universe. That level of insight was both exhilarating and deeply unnerving. Furthermore, the AI enabled visualization of the signal in ways never attempted before. Fractal representations, temporal layering, and morphing simulations allowed the team to see the data as a dynamic structure. These visualizations made abstract concepts tangible, offering the audience a sense of the signal's magnitude and complexity. It became apparent that the anomaly was not merely data. It was a multidimensional experience, demanding new methods of comprehension. Yet AI raised its own ethical and philosophical questions. By decoding the signal, are we participating in shaping the future it originates from? Can an algorithm's interpretation carry unintended consequences? And if the AI learns the future, does that knowledge influence the present? These questions blurred the line between observer and participant, highlighting that even technology is not neutral when faced with phenomena that challenge causality. Ultimately, AI became both a magnifying glass and a compass, revealing patterns while guiding the scientists through uncharted territory. It transformed the signal from a cryptic anomaly into a navigable landscape of possibility, unlocking perspectives that human intuition alone could never reach. The collaboration of human curiosity and artificial intelligence allowed the team and viewers to approach the incomprehensible in ways that were thrilling, terrifying, and impossible to ignore. Working with the signal wasn't just a scientific challenge. It became a psychological ordeal. The team spent long nights immersed in patterns that seemed almost alive, constantly shifting, teasing comprehension, and resisting interpretation. Over time, the constant exposure began to affect perception, mood, and cognition. Even seasoned researchers reported feelings of disorientation, unease, and subtle paranoia. Some scientists described experiencing temporal dissonance, the sensation that time was stretching, compressing, or looping around them. Hours would pass in what felt like minutes, or vice versa. Dreams became vivid, often involving fragments of the signal itself. Some reported hearing the pulses when awake, as if the signal had invaded their senses. Others described fleeting visions of events that hadn't occurred, or encounters with people they hadn't met. The boundary between reality and projection began to blur. Stress levels escalated. Meetings that would normally involve calm debate turned into tense discussions, as uncertainty and fear amplified disagreements. Skeptics accused colleagues of over-interpreting the data, while believers worried that delay in action might have consequences in the future. The weight of potential responsibility, deciphering a message from a time yet to arrive, created an almost unbearable psychological strain. Even outside the lab, the effects persisted. Researchers found it difficult to concentrate on daily tasks. Simple routines, once comforting, now felt disconnected from the larger mystery. Relationships strained as colleagues became obsessed with patterns and timestamps. Sleep became irregular, punctuated by dreams in which the signal replayed itself in surreal, often disturbing sequences. Some even reported a sense of being observed, as if the signal's origin was aware of their attention. The team implemented coping strategies, scheduled breaks, peer counseling, and mental health monitoring. Yet the psychological impact persisted because the anomaly was fundamentally unknowable. Human minds crave order and explanation, but the signal offered ambiguity and infinite possibilities. It demanded engagement on a level that was simultaneously intellectual, emotional, and existential. The effects also reinforced the high stakes of the discovery. When science begins to impact perception, behavior, and cognition, the phenomenon being studied isn't just external, it infiltrates consciousness. The signal wasn't merely an object of research, it was an experience, a challenge, and a puzzle that required both technical skill and mental resilience. For the audience, understanding the human dimension adds gravity. This isn't just a story of equations, waveforms, and theories. It is a story of people confronting something beyond human comprehension. The psychological strain mirrors what any person might feel when faced with evidence that the universe itself is unpredictable, mutable, and aware. The signal reaches into the mind as much as it reaches into time, leaving no one unchanged. Once news of the signal began to leak, public reaction was immediate and intense. Social media exploded with speculation, ranging from excitement to fear. Headlines alternated between sensationalism and caution. Message from the future and scientists discover impossible signal. The story spread faster than any other scientific discovery in recent history, captivating the imagination of millions around the globe. For many, the signal represented hope. People imagined that the future was reaching back to guide humanity, offering solutions to climate change, disease, and technological stagnation. Communities formed online, debating the meaning of the patterns and sharing interpretations. Art, music, and literature inspired by the signal began appearing almost overnight, reflecting humanity's innate desire to make sense of phenomena that defy explanation. Others reacted with fear. Conspiracy theories flourished, suggesting government cover-ups, impending disasters, or the influence of unknown powers manipulating the timeline. Panic began to surface in some circles, with individuals fearing that even acknowledging the signal might trigger catastrophic consequences. The psychological impact of thinking the future was communicating directly with the present caused anxiety, obsession, and paranoia for some. Media coverage oscillated between rational reporting and sensationalism. Some outlets focused on the scientific rigor, interviewing physicists and AI specialists about the data. Others amplified theories of alien involvement or supernatural explanations, generating mass attention but also confusion. The mix of truth, speculation, and myth fueled public fascination, making the signal a phenomenon larger than the scientific community alone. Government and institutional responses intensified the tension. Official statements tried to calm the public while withholding sensitive technical details. Access to the raw data remained highly restricted, further fueling speculation. In some countries, security agencies closely monitored scientists, fearing that the knowledge could influence global stability or be misused. The intersection of science, politics, and human curiosity created a volatile environment in which misinformation could spread as rapidly as genuine discovery. For the audience, this chapter emphasizes the social dimension of extraordinary discoveries. It is not just about signals and theories. It is about humanity reacting to the unknown. The global frenzy illustrates how awe and fear coexist, shaping perception, behavior, and interpretation. This public response adds layers of drama, revealing that the impact of the signal extends beyond laboratories and into culture, society, and consciousness itself. Ultimately, the media and public reaction set the stage for a critical question. How does humanity respond when confronted with evidence that challenges reality, science, and time itself? The answer is far from simple, and the consequences may unfold over decades, shaping not just knowledge, but civilization itself. As the signal gained attention, governments around the world quietly mobilized. Classified meetings were held behind closed doors with intelligence agencies, military, strategists, and top scientists, debating both the threat and the opportunity posed by the anomaly. The existence of a message from the future, or even the possibility of one, was treated as a matter of national and global security. Agencies began monitoring the flow of information closely, controlling public disclosure while trying to maintain secrecy. The rationale was simple. Knowledge of a temporal anomaly could destabilize economies, influence elections, or trigger panic if misinterpreted. Access to the raw data was strictly limited, often to small teams cleared at the highest security levels. Surveillance of scientists became routine, both to protect them and to prevent leaks. Strategic discussions focused on potential implications. If the signal was a warning, governments needed to understand the scale of the threat and whether immediate action was necessary. If it was intelligence from a future civilization, the stakes included technological advantage, economic dominance, and even potential geopolitical leverage. Yet no one could predict the consequences of interference. Every plan carried risk, because acting on information from an unknown temporal source could fundamentally alter reality. Military simulations were initiated, modeling scenarios based on the most extreme interpretations of the data. Could a future catastrophe be prevented? Could manipulation of the signal itself create paradoxes? Analysts debated the possibility of preparing for events that might not happen, or worse, creating them through misinterpretation. The tension between caution and ambition was palpable, revealing how deeply the signal challenged conventional frameworks of planning and control. The involvement of secret agencies added layers of intrigue and danger. Some scientists felt pressured to prioritize national security over open research. Whistleblowers and leaks became potential threats, forcing the research team to operate in high-stakes secrecy. The signal's existence now carried political weight, not just scientific significance, transforming a pure intellectual pursuit into a complex battlefield of knowledge, ethics, and power. For the audience, this chapter heightens the stakes. The signal is no longer an abstract mystery. It has real-world consequences, influencing governments, security agencies, and global decision-making. The narrative shows that humanity's encounter with the unknown is not only intellectual, but also political, ethical, and existential. Every action, or inaction, has ramifications that ripple across time, emphasizing the fragility and responsibility inherent in dealing with forces beyond comprehension. Once patterns within the signal became somewhat interpretable, the question arose: could humanity respond? Scientists and AI specialists debated the possibility of sending a return message. If the signal was intentional, an answer might be expected, forming a two-way dialogue across time. If accidental, transmitting could risk creating paradoxes or attracting consequences beyond understanding. The first attempt was cautious and methodical. Using the same high-precision radio arrays, researchers encoded simple sequences into the medium they believed carried the signal. The sequences were designed to be unambiguous: mathematical constants, prime numbers, and basic physics formulas. The hope was that if the signal originated from an intelligent source, these universal symbols would be recognized and interpreted correctly. Timing was crucial. Sending a message too early or too late could prevent detection, or worse, distort the temporal alignment that allowed the initial signal to appear. Teams synchronized clocks to the nanosecond, accounting for every variable they could measure. The lab became a hub of tense focus, where a single miscalculation could render the attempt meaningless or even dangerous. As the transmission began, everyone held their breath. Monitors displayed both outgoing sequences and the ongoing waveform of the signal, waiting for any reaction, however subtle. Moments stretched into hours, each one amplifying anticipation. Some patterns in the waveform began to shift, faint but noticeable, hinting at the possibility of recognition or response. But interpretation remained uncertain. Was the change an echo, a glitch, or a deliberate acknowledgement? The psychological weight on the researchers was immense. For the first time, they realized that they were not merely observers. They were participants in a communication across time. Every adjustment, every calculation carried responsibility. The very act of attempting to respond challenged their understanding of causality, introducing the possibility that present actions could influence unknown futures. Even in this early stage, the implications were staggering. If successful, the exchange could mark the first verified interaction between present-day humanity and intelligence, whether human or alien, from a future or parallel timeline. If misinterpreted, it could create ripple effects across time itself. The lab was both a sanctuary and a crucible, a place where curiosity, fear, and hope collided, and where humanity's first steps into temporal dialogue were being taken with equal parts awe and trepidation. As the first attempts at communication unfolded, the AI began revealing deeper layers of the signal, patterns nested within patterns, fractal-like structures that repeated at multiple scales. What initially seemed like random bursts of energy now revealed sequences that mirrored themselves in ways that were almost hypnotic, suggesting a level of complexity far beyond human design. Each pulse was not isolated. It was part of a web, a multi-dimensional lattice of information that could encode multiple realities simultaneously. Researchers realized that to interpret these sequences, they had to shift their thinking entirely. Conventional linear analysis was useless. Instead, they employed recursive algorithms, multi-layered neural networks, and temporal simulation models, treating the signal as both data and architecture. The deeper they dug, the more it felt as if the signal was alive, constantly adjusting and reorganizing itself in response to observation. Some sequences even hinted at self-reference. Portions of the signal appeared to encode information about the signal itself, like a blueprint embedded inside its own structure. This recursive quality suggested not only intelligence, but foresight. The possibility that the entity or phenomenon behind the signal anticipated humans trying to decode it and designed the message to be discovered gradually. Each level revealed a new layer of meaning, but understanding it fully seemed almost impossible. The psychological impact was profound. Scientists often stared at screens for hours, seeing familiar sequences morph into unfamiliar shapes, their minds straining to detect meaning in what might be an intentionally complex puzzle. Sleep became erratic as dreams began to echo the fractal sequences. Some researchers reported feeling as though they were inside the waveform, navigating a structure that defied spatial and temporal logic. The discovery of these nested patterns also intensified debate. Were they the product of a future civilization carefully designing a temporal message, evidence of parallel realities communicating indirectly, or a cosmic glitch that accidentally created layers of information? Each interpretation carried weighty consequences, challenging both science and philosophy. For the audience, this chapter emphasizes awe and tension. The signal is no longer a single anomaly. It is a labyrinth, a multidimensional construct that defies comprehension, yet beckons humanity to explore. The patterns within patterns reinforce the sense that we are witnessing something monumental, a phenomenon that challenges the very way we understand information, causality, and the flow of time. As the team continued transmitting, something unprecedented occurred. The signal began to respond. Not in full sentences, but in patterns that mirrored the sequences sent from the lab. At first it was subtle, a single pulse delayed by fractions of a second. Then repetitions became more pronounced, resembling a rhythm or dialogue. The waveform seemed aware, almost sentient, reacting to human input in ways no one expected. The room erupted in a mixture of awe and fear. Scientists realized they were no longer passive observers. They were participants in a temporal conversation. Every sequence they sent was being acknowledged, every pause observed. The implications were staggering. The signal might not just originate from the future. It might be communicating, guiding, or testing humanity. Psychologically, the team felt the weight of responsibility. Could their responses alter the timeline? Were they unknowingly creating paradoxes? The line between discovery and interference blurred. Each pattern required careful analysis. Each response was a decision with consequences unknown. The room, once a lab, now felt like the bridge between epochs, a threshold between present and future. The AI became indispensable, decoding hints, embedded in the responsive patterns. Sequences suggested timing, coordinates, and abstract concepts, clues that seemed designed to challenge human perception. It was as if the entity behind the signal was intentionally revealing itself incrementally, ensuring humanity could grasp the basics before confronting the deeper truths. The atmosphere was tense, charged with excitement and dread. Every pulse carried meaning, every repetition demanded attention. The scientists were acutely aware that this was no ordinary interaction. The signal had evolved into an active force, shaping their actions and testing the limits of human comprehension. After weeks of analysis and cautious interaction, the team finally reached a breakthrough. The signal was not merely a message from the future, it was a construct designed to preserve and transmit knowledge across time. Its origin was neither accidental nor purely natural. The nested patterns, fractal sequences, and adaptive responses revealed intelligence of a magnitude beyond current human understanding. The revelation sent shockwaves through the lab. The signal was not a static message, but a temporal architecture, a living conduit of information from a future humanity, or perhaps a parallel civilization, that had mastered time itself. It was both a warning and a guide, offering insights into survival, technology, and the trajectory of civilization. The complexity of the data suggested foresight, strategy, and ethical consideration, implying that whoever or whatever had sent it intended humans to engage responsibly. The team realized that the signal carried multi-layered instructions. Some were technical, providing frameworks for understanding advanced physics and potential solutions to global crises. Others were philosophical, challenging human perception of morality, causality, and free will. The deeper the AI decoded, the more it became clear that the signal was a test, a careful orchestration to determine whether humanity could comprehend, respect, and act upon knowledge that transcended time. Emotions ran high, excitement mixed with fear, as each new layer of understanding brought ethical dilemmas. Could humanity responsibly act on knowledge from the future? What if misinterpretation caused disaster? The scientists faced not only intellectual challenges but moral imperatives. Their decisions would shape not only their present, but possibly countless future timelines. At this moment, the signal became a mirror. Humanity was confronted with its potential for creation or destruction, for insight or chaos. It was a revelation that transcended science. It was existential. The team was no longer merely decoding data. They were communing with the consequences of time itself, standing at the precipice of understanding the universe in ways previously unimaginable. With the true nature of the signal revealed, tension within the lab reached its peak. The team faced a profound dilemma: act on the information and risk unintended consequences, or observe cautiously and potentially forfeit an opportunity to prevent catastrophe. Each decoded pattern presented options, warnings, and instructions that could alter history or destroy it. Debates grew heated. Some scientists argued for immediate action, believing that humanity's survival depended on embracing the knowledge and implementing it as soon as possible. Others urged restraint, warning that interfering with temporal signals could create paradoxes, ripple effects, or irreversible changes. Every pulse, every pattern became a decision point, a crossroads between progress and peril. The media and government pressure intensified the stakes. Leaks had occurred, fueling public demand for transparency and action. Officials demanded answers and immediate application of the signal's insights, while internal teams cautioned that rushing could trigger disaster. The scientists were caught between public expectation, national security, and cosmic responsibility. Even the AI highlighted risks. Its simulations predicted multiple outcomes based on potential responses, including timelines where intervention accelerated disasters or created previously non-existent crises. Humanity's choices were no longer hypothetical. They were actionable variables in a complex temporal system, with consequences extending beyond comprehension. Psychologically, the strain was immense. Anxiety, sleeplessness, and self-doubt grew as the team wrestled with questions of morality, responsibility, and the limits of human understanding. Each decision carried weight beyond ordinary science, pushing them into territory where ethics, psychology, and physics converged. The tension was palpable, not only for the team, but for the audience experiencing this high-stakes narrative. The rising tension set the stage for the climax. Humanity was at a threshold where action and understanding had to converge. The signal demanded response, yet warned that a misstep could unravel everything. Every viewer was now acutely aware that the resolution would not simply be discovery. It would be decision, consequence, and revelation rolled into one moment of temporal confrontation. As the team implemented a coordinated response to the signal, the temporal anomalies intensified. Monitors flashed sequences at speeds that seemed impossible, waveforms layered over each other, forming complex lattices of data that mirrored future events. Time itself appeared to ripple within the lab, and even the AI struggled to maintain coherence in its models. Suddenly, sequences began aligning across multiple timelines. Patterns that were once isolated now synchronized, forming an unmistakable order. It was as if reality itself was converging toward a single point, a nexus where past, present, and future intersected. The scientists understood that they were witnessing the physical manifestation of the signal's ultimate design, a moment when all the hidden layers revealed their purpose. The intensity of the data created a palpable sensation of pressure and urgency. Every choice the team had made, the sequences sent, the pauses observed, the analytical methods applied, was contributing to the unfolding convergence. The lab became a vortex of causality, where actions and observations no longer felt discrete, but intertwined with outcomes yet to unfold. Fear and exhilaration coexisted. The team realized that the signal was not just information, it was a temporal experiment, testing whether humanity could handle the responsibility of knowledge and action across time. The magnitude of the event was overwhelming. This convergence could confirm the existence of a future civilization, create a temporal paradox, or provide the knowledge to prevent catastrophic events. Viewers experienced the climax through the same immersive lens. Rapid synchronized visualizations show waveforms colliding and merging, while AI simulations highlight branching consequences collapsing into singular pathways. It is the pinnacle of tension, the moment where comprehension, courage, and consequence meet. The narrative drives home that this is no ordinary discovery. It is a collision of timelines, a test of humanity's capacity to understand and act when confronted with the impossible. At the peak of the temporal convergence, the signal revealed its ultimate purpose. The chaotic layers, nested sequences, and responsive patterns coalesced into a coherent structure, conveying a profound truth. The signal was designed to preserve the continuity of intelligent life across time. It wasn't simply information. It was a blueprint for survival, evolution, and ethical advancement. The patterns illustrated potential futures, some prosperous, others catastrophic, showing the consequences of choices yet to be made. The message emphasized that knowledge without responsibility could accelerate disaster, while careful interpretation and action could guide humanity toward a path of resilience and enlightenment. It was a test, a warning, and a gift all at once, sent across time to ensure that those who received it would act with foresight. The scientists watched in awe as the data formed symbols and sequences that conveyed more than raw science. Concepts of morality, strategy, and decision-making were embedded directly within the signal's structure, intertwining logic and ethics. The realization hit that the signal was not merely instructing, they were being trained, guided to think
in ways that transcended linear causality. The climax intensified as each researcher grasped their role in the unfolding event. The AI helped decode the final layers, revealing instructions that required human intuition and judgment alongside
algorithmic precision. The integration of human and machine understanding became essential. Only through collaboration could the message be fully comprehended and acted upon. For the audience, this revelation is both awe-inspiring and sobering. The signal demonstrates that the universe, or the intelligence behind it, operates on scales and principles far beyond our normal perception. It challenges viewers to consider their own potential role in shaping future outcomes, reminding them that responsibility, understanding, and foresight are inseparable from discovery. The narrative now stands at the precipice, preparing for the final resolution, where consequences, ethics, and human action converge. With the full scope of the signal understood, the team faced the ultimate challenge: action. The message was no longer abstract. It required decisions, intervention, and coordination. The nested patterns provided guidance, but interpretation remained critical. Every choice had the potential to shape timelines, prevent catastrophe, or, unintentionally, create new anomalies. The lab became a command center of calculated risk. Sequences were sent in carefully timed intervals. Simulations verified potential outcomes, and contingency plans were established for every possible scenario. Scientists debated priorities, which instructions to follow first, which to delay, and which might carry hidden consequences. Their choices were not simply scientific, they were ethical and existential. The psychological intensity was profound. Some researchers hesitated, fearing mistakes that could ripple across time. Others embraced the challenge, realizing that inaction was as dangerous as misinterpretation. Trust between team members became essential, as collaboration determined the success of every response. Each human decision was amplified, mirrored, and tested by the AI, creating a feedback loop between thought, action, and temporal consequences. As they executed the plan, the waveform shifted dynamically, responding to human input in near real time. Subtle changes indicated that the signal was monitoring, adjusting, and confirming their choices. It was no longer merely a message, it was a dialogue, a partnership across time. The researchers understood that they were co-authors of an outcome that spanned generations, bridging present action with future consequence. For the audience, this moment delivers maximum suspense and engagement. Humanity's role in shaping its own destiny is central, emphasizing responsibility, courage, and intellect. Every pulse and response carries weight, highlighting that discovery alone is meaningless without the wisdom to act. The narrative tension peaks here, setting the stage for the resolution, reflection, and the story's memorable flourish. After the team's carefully coordinated actions, the temporal turbulence began to stabilize. Waveforms that had previously danced chaotically across screens now aligned into coherent, repeating patterns. The signal's energy, once unpredictable and volatile, settled into a rhythm that suggested successful interaction and comprehension. It was the moment where the impossible became tangible. The convergence of timelines had been guided to equilibrium. Relief and awe swept through the lab. Scientists realized that their decisions, guided by the AI and their own intuition, had prevented potential paradoxes and mitigated risks embedded in the signal. The once overwhelming chaos of nested patterns and fluctuating sequences had been transformed into an organized, meaningful structure. Humanity had passed the test the signal presented, proving its capacity to understand, respond, and act responsibly. The AI confirmed the outcome. Predictive simulations indicated that the stabilized signal would continue to provide insights, now interpretable in a controlled, safe manner. The knowledge embedded in the signal could now be analyzed without fear of destabilizing reality. The future, though still uncertain, was no longer opaque. Through careful action, the team had carved a path forward, demonstrating that intelligence and ethics could coexist in a high-stakes temporal environment. Emotionally, the climax left the researchers transformed. The experience had tested not only their intellect but their resilience, moral judgment, and ability to operate under pressure. The signal had forced them to confront the limits of human understanding, yet in doing so, it had expanded those limits, offering a glimpse of what humanity could achieve when faced with the extraordinary. For the audience, this chapter provides the catharsis of resolution. The tension built over hours of observation, decoding, and ethical deliberation reaches its peak and then releases. The narrative now transitions into reflection and closure, offering space to explore the implications of the discovery for science, philosophy, and the human experience. With the signal stabilized and its purpose understood, the story enters reflection. The lab, once a place of tension and uncertainty, became a symbol of human potential. The researchers had not only decoded a message from across time, they had engaged in a dialogue that bridged generations, dimensions, and possibilities. Humanity had been tested, and had proven capable of responsibility, foresight, and collaboration on an unprecedented scale. The implications extended far beyond science. Ethical frameworks, philosophy, and cultural perspectives all shifted as society grappled with the reality that information from the future was now accessible. Governments, educators, and institutions began integrating the knowledge, guided by lessons embedded in the signal. The future is shaped not only by technology but by judgment, cooperation, and moral clarity. The signal remained active, a constant reminder that time is not linear, but a network of potentialities. Humanity now stood at a threshold, empowered by insight, yet humbled by the responsibility it entailed. The final sequences suggested continuous guidance, but only if approached with wisdom and integrity. It was a promise, a challenge, and an invitation. A glimpse of what could be achieved when intelligence, ethics, and curiosity aligned. For the audience, the conclusion leaves both awe and contemplation. The story closes with the understanding that discovery is never just about knowledge. It is about how that knowledge is used. Humanity's horizon had expanded, revealing that the universe is not merely a backdrop for existence, but an interactive, responsive dimension where action, understanding, and choice resonate across time. The flourish is subtle, yet profound. A universe that speaks, listens, and invites participation, leaving viewers inspired, thoughtful, and aware of the possibilities that lie beyond the present moment.